Okay, dear students, we are in exercise 5.1. In the last class, we have finished up to question number 18. Okay, now let us take question number 19 onwards and let us finish as many problems as. See, show that the function defined by gx is equal to x minus bracket x. What is that bracket x? That bracket x is a greatest integer function. Okay, greatest integer is discontinuous at all integral points. Here bracket x is the greatest integer less than or equal to x. Okay, before proceeding, let us understand greatest integer function once again. Okay, this greatest integer function. Okay, greatest integer function, I am keeping here input or domain, here range or output. Okay, what are all will come, you simply observe first. If I give 0, 0 will come. If I give 1, 1 will come. If I give minus 1, minus 1 will come. 1 will come. Okay, greatest integer function. What if I give 0.5? 0 will come. You understand? That is the specialty of greatest integer function. What if I give 1.5? 1 will come. What if I give minus 0.5? Minus 1 will come. In minus side, minus less. Minus less means minus 1 is less than minus 0.5. That is why less number integer will come. What if minus 1.5? Minus 2 will come. This is the specialty of greatest integer function. You see, this is a real line. Okay, minus infinity plus infinity. Here 0 will be there. Here minus 1 will be there. Here 1 will be there. Here 2 will be there. Here 3 will be there. Here minus 2 will be there. Okay, you see, this function speciality is it gives output of only integer. Fraction it will omit. Okay, you see, if you give integer, integer will give output. If you give fraction, then in that fraction, what is integer that it will take and it will give output. You see here what I am telling. 0 you have given here, 0 has come. Why? Because 0 is integer. Minus 1 you have given, minus 1 it has given out. Why? Because minus 1 is integer. 0.5 here, you see here, this is 0.5. 0.5 you have given, but 0.5 it will split. 0 plus 0.5. Integer is 0. It will give only 0. 0.5 it will omit. It will split and it will omit. Okay? Or else I can say like this. 0.5 if you give, it will make 0 plus 0.5. Okay? Separate. And 0 only it will give out. 0.5 it will omit. Okay. What if minus 1.5? It will make minus 2 plus 0.5. Then minus 2 it will give out. Okay. You see minus 2. You see here minus 1.5 means it will be here. Okay. Least is minus 2. Once it crosses minus 1, then least will be minus 1. Once it crosses 0, least will be 0. Once it crosses 1, least will be 1. Once it crosses 2, least will be 2. Okay. That means greatest integer, whatever may be the fraction you are giving, it will split integer and fraction. What is the greatest integer? Greatest integer 1 only. See, even if you give 1.999 also, it will split 1 plus 0.999. But which is greatest integer? Greatest integer is this one. This is not integer. Then it will give out 1 only. Okay, that is the specialty of this one. Now you tell me, right hand limit, left hand limit, is it going to survive? No. Why? Because see, slightly less than 1 means what will come? 0 will come. Slightly greater than 1 also 1 will come. left hand limit, right hand limit. What I want to say, see 2 you have taken 2. I am writing here again 2. Slightly less than 2 you have given, but rather than 2 it gives 1. Greatest integer function. Slightly greater than 2 if you give 2 it will give. Slightly greater than 2 means right hand limit there is no problem. Why? Because output you are getting 2. 2.00001. If we give, then 0.0001 it will omit and 2 it gives. But what about 2? Slightly less than 2. Slightly less than 2 means what you are giving? You are giving 1.999999. Then what it is going to do? It is going to give only 1. It won't give 2. Then left hand limit will be 1. Right hand limit will be 2. Both are not equal. Then automatically the greatest integer function is discontinuous. Okay. This we know. But here not only this, again they have given x minus greatest integer function. You see, any two functions are there, addition or subtraction, algebra function, both continuous means it will become continue. If any one is discontinuous means automatically total function is going to become discontinuous. That's all. Okay. Let us proceed for original problem. Now what we have to take, we know very well, na? Now what integer we are going to take? Any one integer we have to take. Let us take it as k. Why? Because always we take integer as k, scalar. Let x is equal to k, k be any integer. Let x is equal to k, k be any integer of domain minus infinity to plus infinity. Okay. From domain, of domain, whatever it may be. Okay. K may be any integer from minus infinity to plus infinity. But open bracket I am putting. That means minus infinity you should not take, plus infinity also you should not take. K domain you have taken. Okay. Now let us apply this. Continuity at k. Continuity at k. Okay. Limit extends to k g of x. Why? Because you don't write f of x. Here g of x they have given. G of x that is equal to. Okay. Then limit extends to k x minus bracket x. Actually this we should call as greatest integer function x, but nobody call that much bigger. You call simply bracket x. So afterwards we will treat it as a greatest integer function. Okay. Okay. Now you substitute that is equal to, I am substituting k minus greatest in this one bracket k. That means k minus k that is equal to 0. Is it okay? First you see. Why? Because k is integer we have written already. Let k be any integer. Integer we have written. We have not written any real number. Real number means what will come? Or else we will write like this. K is any integer from z is equal to minus infinity to plus infinity. Okay, why? Because normally we take z for integers. Okay, that is why I have taken z. Some books they give I also integer. This should be integer, or else our theory is going to fail. That keep in our mind. Why? Because real number you should not take. Real number means 1.5 also real number only. Okay. Okay. See, now what will happen? This is a limit at k. But left hand limit, right hand limit also have to take. Continuity means, okay, continuity we are checking, na? Continuity we are checking, we have to take left hand and right hand limit also. Let us take left hand limit. Right hand limit is same will come. Left hand limit we will take. Left hand limit. Left hand limit comma limit extends to k minus. Left hand means k minus we have to take. K minus g of x is equal to limit extends to k minus x minus bracket x. Okay. Now you tell me what you are going to substitute. K minus minus k minus. Is it okay? Definitely okay. Now you tell me k minus approximately, see, this is not a greatest integer function. This is a normal function. For normal function, slightly less than k, slightly greater than k, what we are taking? Unless it is in division. Unless it is in division or special function, normally k minus or k plus we are going to take as k only. Okay, k minus. Okay, that we know. But in function, special function, this k minus is what going to happen? For the sake, you take k as 2. Slightly greater than 1, slightly greater than 2, if you give 2 will come. That means slightly greater than k means k plus. If you give k will come. But slightly less than k, less than 2, if you give what will come? 1 will come. 1 means here what? If k is 2, 1 is k minus 1. You understand? That means slightly less than k if you give, and in greatest integer function, it will give k minus 1. But it in bracket. Okay? Even 1.99999 also, it will give 1 only. That means if k is 2, approximately, see, k is any general number we are giving. Why? Because we cannot show out only one number. K minus 1 will come. K minus 1 means what happens? K minus k plus 1, that is equal to 1. Okay, see here itself we can say that this limit is varied. But even then we will see right hand limit also. As per procedure, we have to see right hand limit also. Okay, let us see right hand limit. Even with these two also you can write left hand limit and main limit are different. That is why the function is discontinuous. Why? Because he is asking us to show that the function is discontinuous at integral points. Integral points only, integer only. That is why I have told you to take only integer here. Keep in your mind. K is any integer, like we have told. Because at integral points we have to show. Integral means not integration. Integral means integer, like we have to take. Okay. Let us proceed for the right hand limit. Comma, limit x tends to k plus g of x is equal to limit x tends to k plus x minus bracket x. Is it okay? Definitely okay. Okay, now substitute, that means apply limit, that is equal to k plus means k plus only you take minus k plus. If you write here, then here also you have to write. But here k plus you have given, okay. But you see, finally output from greatest integer function what will come? K plus means k only. Okay, what will come? K only. What is this k plus? K plus also k only. Approximately k. This also you can take k. Okay. What will come finally? 0. You see, here is 1, here is 0. Left hand limit is 1, right hand limit is 0. Is this the function continuous? No. Discontinuous. Discontinuous at where? Discontinuous at integral point. Okay. Why? Because k is an integer. At integral points, the function has become discontinuous. Okay. Now, exactly if we speak, what is happening here? You see, k minus is slightly less than k. Slightly less than k. Even if you keep k minus like this or like this only, but this is k minus 1 will come. K minus 1. K minus 1 will happen. K minus 1 means even if you see slightly greater than 1 will come here. But here slightly greater than 0 will come. That you keep in our mind. Even if you give exactly also, say for the namesake, we will give here 2. Say k is 2. You imagine for some time k is 2. K minus means what will come here? 1.999. But this is 1.999. minus. Here what will come? K minus minus 1. Why? Because this function, greatest integer function, is making it minus 1. K minus minus 1 means what will happen? 1.999 is going to become 1. Why? Because it is going to become integer. Then what will become? 0.9999. That means we can say this is approximately 1. See, this is approximately equal to. This is equal to. Okay? Approximately equal to 1 has become left hand limit. Left hand limit. See, for conceptual sake I am telling. You can write directly 1 and 0. That is not wrong. But conceptual sake I am telling. Come here. Here k plus means what it will come? 2.000001. Approximately. Okay, we have taken. Here also k plus you have given 2.001, but output here k plus 1 like that only it has come. You think why 2.001? But this will make what? This will make 2. Why? Because it will not keep integer function integral parts only. It will send out. That means 2.001. Even if you give, it will send out 2 minus 2. What will come? That means approximately equal to 0, I can say. Why? Because 0.000001 means you can say that is approximately equal to 0. Approximately equal to 1 and approximately equal to 0. For the namesake, we can say left hand limit is approximately equal to 1. Right hand limit is approximately equal to 0. That means both are not equal. Both are different. That means the function is not continuous. Like that we can declare. Okay. This is for understanding sake I have told, but you have to write this only 1 and 0 only for examination. Okay. So now what we are going to write? We are going to write like this: left hand limit not equal to right hand limit. Therefore, the function is discontinuous at integral points. Okay, write down. Left hand limit is not equal to right hand limit, comma, therefore the function is not discontinuous at integral points. Okay, you understand now? You take this, we will go for 20th question, question number 20. Okay, see the 20th question. Is the function defined by f of x is equal to x square minus sin x plus 5 is continuous at x is equal to pi? Okay. Now you tell me, this function we can take as algebra of functions. Why? Because 3 functions like you take. X square is one function, sin x is another function, 5 is one function. That means you don't take this as fx. Fx is equal to x square, gx is equal to sin x, hx is equal to 5 like you take. In imagination, 3 functions are there. Addition and subtraction of function at only one area, is it continuous? Continuous only. Why? Because see, x square at pi is continuous, x square at 5 is continuous. Why? Because 5 is a scalar function. It is continuous always irrespective of input. Sin x is continuous. We already proven or we already studied. Once again we will see in the next question. Okay, once again we will write. For this we need not write that again, proof of sin x. Okay, sin x is also continuous. Why? Because sin pi, if you give 0, left hand right hand slightly equal to 0 only, it is going to come. That is why this function is continuous. Individually those are continuous means even in algebra also those are going to become continuous like we know. Okay, that means see, we are going to write this function as continuous, but we should know whether it is really continuous or not. Continuous only. Then we will write simplest way. We will close this problem. How we are closing, you see, simplest way I am writing. Okay, you see, f of x is equal to x square minus sin x plus 5. F of pi is equal to pi square minus sin pi plus 5. That is equal to sin pi is 0. Okay, pi square plus 0 plus 5. Sorry, minus 0. That means pi square plus 5. Okay, now we will apply limit. Limit also, if it comes pi square plus 5, this function is continuous. That's all. Like this also we can write and close. Sometimes you have to do these steps also, tricks or steps, whatever it may be. Limit extends to pi, f of x is equal to, limit extends to pi, okay, x square minus sine x plus 5. That is equal to, if you apply limit, pi square minus sine pi plus 5. Pi square minus 0 plus 5. That is equal to pi square plus 5. Okay. LHS is equal to RHS. No, not LHS. We have to write like this. You see, like this you write. F of x is equal to limit x tends to pi f of x. Okay. Therefore, the function is continuous at x is equal to pi. At x is equal to pi, you have to write like this. Okay. Therefore, the function is continuous at x is equal to pi. Like this, you can write and close. Why? Because see, we know that sin x is a continuous function. See, unless it is continuous, we cannot do differentiation. Differentiation of trigonometric function, big chapter. Okay, all trigonometric functions are continuous, but conditions will apply. For sine and cos, no bar. But for tan, 2n plus 1 pi by 2, you have to minus domain from R. Like that, conditions are there. Okay, we will see all those. Don't worry. Okay. Now, if you write this close, then there is no problem. You will get full marks. Let us go for 21st. See the 21st question. Discuss the continuity of the following functions. That means we have to discuss the continuity of the following functions. F of x is equal to sin x plus cos x. F of x is equal to sin x minus cos x. F of x is equal to sin x into cos x. Okay. Now you tell me, sin x is continuous? Yes. Cos x is continuous? Yes. Then we will take sin x and cos x as gx and hx, algebra of functions. Hx plus gx is equal to continuous. Fx is equal to gh plus hx, continuous. Why? Because see, when these functions are continuous at x is equal to any c. Why? Because see, we have to tell that continuity at any one point. Algebra in that they have told that if your function f is continuous at x is equal to c, and another function g is continuous at x is equal to c, then f plus g is also continuous at x is equal to c. That means that c we have to take here. Okay. Like that we have to think. In the last question they have given pi. That is why in pi we have proved. But here algebra they have not given anything. What we do? Simply see, if sin x is continuous you prove, cos x is continuous you prove. What we'll do? We'll do, let sin x is equal to gh, cos x is equal to hx, continuous at c, any c, then f of x is equal to sin x plus cos x, let x is equal to c. These are also continuous, like we will write. Just write. Okay. What you have to prove? You have to prove only sin x is continuous, cos x is continuous. If you prove those automatically, and as per algebra of functions, we will write f of x is equal to g of x plus h of x. Both are continuous because sin x and cos x are continuous at x is equal to c. And this function also continuous at fx is continuous at x is equal to c. See, sin x is continuous at x is equal to pi. Cos x is continuous at x is equal to pi by 2. You cannot write that sin x plus cos x is continuous. X is equal to pi means x is equal to pi only. You have to see continuity. Okay. Like that you have to write. Why I am telling, see, sin x cos x may be okay. But if it comes to tan x, sine is continuous at pi by 2, but tan is not continuous at pi by 2. Why? Because at pi by 2, tan is not defined. This logic you have to understand. Okay. Let us proceed to continuity of sin x and cos x. I am writing here, you see, continuity of sin x. Okay. And continuity of cos x. Okay. Okay. See, for this you have to take any one point. That point I am writing, you see carefully. let x is equal to c plus delta x. You keep in your mind, x is equal to c plus delta x. Here also I am writing, let x is equal to c plus delta x. Okay. You see how I am proving this. F of x is equal to sin x. F of x is equal to cos x. Okay. F of c is equal to sin c. F of c is equal to cos c. Okay. This I am making one box. Why I will tell afterwards. Okay. Now you see what I am doing. F of x is equal to sin x. F of c is equal to limit x tends to c sin x. Okay. Like this I have written. You see now what I am doing. That is equal to x is equal to c plus. See here what I am writing. C I have replaced with delta x. Okay. X tends to c means delta x is equal to delta x tends to what? You see what I am writing. If x tends to c, delta x tends to 0. Is it correct? First you observe this. If x tends to c, delta x tends to 0. Why c we have taken? C we have to take any one constant. Why? Because in generalized form you cannot write where is this continuity at one point. At that point is c. Okay. X tends to c, delta x tends to 0. Why? See, x is equal to c plus delta x we have taken. If delta x is 0, automatically x tends to c only it is going to become. You see, x is equal to c, delta x equal to 0. Okay, like that we have written. Okay, now you write here. This limit x tends to c, sin x is equal to, what will happen here? You see, this will happen like this. Limit delta x tends to 0, sin x plus delta x, c plus delta x, sorry. Have you understood this? Why I have written? Why? Because see, x you have replacing c plus delta x. When x tends to c, delta x tends to 0, it will become. Okay. Now you see what will happen. That is equal to limit delta x tends to 0, sin a plus b, sin a cos b plus cos a sin b. Sin a cos b plus cos a sin b. Is it okay? Definitely okay. Okay. Now you split limit delta x tends to 0, sin c cos delta x plus limit delta x tends to 0, cos c sin delta x. Is it okay? Definitely okay. Okay. Now you apply limit. Sin c cos delta x means 1. Why? Because 0 if it becomes, automatically sin c into 1 plus here also cos c. If sin delta x, sin 0 means what? 0. That means sin c. Why? Because sin c into 1 is sin c, cos c is 0. Okay. Now you see sin c has come. F of c is equal to sin c. That means you can write f of x is equal to sin x is continuous at x is equal to c. That you keep in your mind. Like this you write it. F of x is equal to sin x is continuous at x is equal to c. Why? Because this c is important. Again, for generalized form, both also we are going to write this c. Same like I am doing continuity of cos x also, you see. Why? Because see, FC is equal to sin C has come. FC is equal to sin C has come finally. That is why LHS is equal to RHS you can write. Okay. And f of x is equal to sin x is continuous at x is equal to c. Like that you write. Now let us go here. Let us go here. What will write? Cos x cos c also. See, if f of c, this I need not write again. This f tends to c, delta x tends to 0. Okay. I am writing like this, you see. F of x is equal to cos x. F of x is equal to cos x, comma. F of c is equal to limit x tends to c sin x. Okay. That is equal to limit delta x tends to 0. Cos we have to write, na? Cos. We have forgotten. Here I will write cos x. Okay. You see now what I am writing. That is equal to limit delta x tends to 0 cos c plus delta x. Why x is equal to c plus delta x we have taken. Delta x, why we have taken? See, delta x is very minute, small. I am telling na, limit slightly less than 0, slightly greater than 0. That or like we can take slightly less than c, slightly greater than c. That one is this one, delta x. Slightly means this is a slight delta x. Delta x always gives you a very small change. Small change is delta x. Okay. Okay. C plus delta x we have given. Okay. Now what we'll do? First of all, you expand this. Okay. You expand this. Same you write like this only. Limit delta x tends to 0. See, cos a plus b. Cos a cos b minus sin a sin b. Cos a cos b minus sin a sin b. Is it okay? Cos c cos delta x minus sin c sin delta x. Okay, we have written that also. Okay, now you see that is equal to, you split this. Limit delta x tends to 0 cos c cos delta x minus limit delta x tends to 0 minus sin c sin delta x. Okay. Now you apply limit. You apply limit. If you apply limit automatically here, cos 0 is 1. Cos c into 1. Minus is there. Minus sin 0 is 0. If you apply limit, that means this is going to become sin c into 0. Finally, what you are going to get? You are going to get cos c. Okay. See here also cos c. Fc is equal to cos c. Again, Fc is equal to cos c. Fc is equal to cos c. That is why you can say that the function is continuous at x is equal to c. Okay. See, this is proof. Like this only you have to do. Okay. Write down. F of x is equal to cos x is continuous at x is equal to c. Okay. See what we are going to write. You first note down this. Again we are going back this one. Okay. Write down this. Sin x is continuous we have proved. Cos x is continuous we have proved. Okay. Separately. Two functions. Say we will take GH and HX. Okay. Write down this. We will go back again. Okay. See whatever we have proved that we have noted down. That will come for this question only. Okay. Now what I am writing, you see. Let gx is equal to sin x and hx is equal to cos x, comma, both functions are continuous at x is equal to c. First you write this. This line is very important. Let gx is equal to sin x, hx is equal to cos x. Both functions are continuous at x. at C. Okay. Now you write this. What you are going to write? You are going to write like this. You see. F of x is equal to g of x plus h of x is continuous at x is equal to C as per algebra of functions, algebra of functions. Okay, like that you write. Okay, now you see f of x is equal to g of x and h of x is continuous at x is equal to C. Why? Because here also x is equal to C, here also x is equal to C as per algebra of functions. Okay, first one is over. Okay, next one also you write. Next one also you write. What you are writing? You are writing like this. This is A. B also I am writing. Okay. F of x is equal to g of x minus h of x is continuous at x is equal to C as per algebra of functions. Is it okay? Definitely okay. Why? Because as per algebra of functions, two functions minus if C, fx is also continuous at C, fx is continuous at x is equal to C here. This is entire function. This function is continuous at x is equal to. Why? Because gx and hx also continuous at a C, like we have already written. This, if you write, then this is valid. That keep in our mind. Okay. Let us proceed further for C. C also. Okay, C. F of x is equal to g of x into h of x is continuous at x is equal to C as per algebra of functions. Okay, that means over. F of x is equal to g of x. Why? Because see, we have already written g of x is equal to sin x, h of x is equal to cos x. F of x is equal to g of x into cos of x means sin x into cos x. Okay, continuous, like we have written, that's all. This will give your answer for your 21st question. Okay, sin x and cos x is continuous, like you have seen. Then you can write like this. Okay, but please keep in your mind, where individual functions are continuous, at only the major function is continuous. Why? Because here we can say fx is major function, these two are minor functions. Gx and hx are two minor functions. Two minor functions you are adding or subtracting or multiplying. Together it is giving a major function, like you think. Third function is continuous at remaining two functions continuity, depends on. Okay, that you keep in your mind. If you don't write this x is equal to x at x is equal to x, see, 50% of marks may cut. That you keep in your mind. Okay, let us go for 22nd question. Okay, see the 22nd question, what they have written. See, 22nd question, for sake one question, but it is 1, 2, 3, 4 questions we can say. Okay, for this question also, again you have to go back this sin x continuity, cos x continuity, what I have done, what we have done in the last question, 21st question. Again you repeat sin x and cos x continuity. Why? Because both are required. Sin x and cos x continuity is basic. Based on that, you can find the continuity of tan x, cot x, secant x, cosecant x, all. Okay, these two continuity you have to write again. See, based on marks you proceed. If marks are not much, then you at x c is equal to, like you take and prove function and limit both equal to, like you show and close the question. Why? Because for less marks means you need not do much proof and all. At least for 4 marks, 4 or higher, then you do this proof. For 2 marks, 1 marks, you need not do that much of proof. Why? Because it is wastage of time. My opinion I am telling. Okay. You see, discuss the continuity of cosine. Cosine function in last question we have done. Same you repeat. See, for both you have to repeat sine and cos. Why? Because for cosecant also we are doing here now. You see, cosine already we have done. Okay. What I am writing, you see. we have proved f of x is equal to sin x and g of x is equal to cos x are continuous at x is equal to c. This you write first. I have written, but you have to prove once again in your examination. Why? Because every question you have to write separately. Sin x, cos x, you have proved, like sin x and gx are continuous at x. See, in this only cosine is there. Cosine means cos. Cosecant means cosecant only. Cosec you call normally. Secant means sec. Secant I will call, you call sec. Cotangent, cot. Okay. Once again you have to prove those. Last question. Okay. Now we are, see, cos x also we have over. Cosecant I am going, you see. Continuity of cosecant x. See, discuss the continuity is writing, na? Continuity of cosecant implies, okay, f of x, g of x is there. I am taking h of x. H of x is equal to cosecant x. Is it correct? Definitely correct. Why? Because see, I have already taken fx is sin x, gx is cos x, then I will take hx as cosecant x. Now with these only I am going to prove all these cosecant, secant, cotangent, but that means cot. That is why I have taken hx is equal to cosecant x. Okay. Now you tell me continuity of cosecant x. Cosecant function. You have to write function here. Why? Because see, continuity of cosecant function. Okay, write down function. Don't write only cosecant. Hx is equal to cosecant x. Okay, now see, we are seeing the continuity of this cosecant x. First I am writing like this, you see. H of x is equal to cosecant x is equal to 1 by sin x. Is it correct? Cosecant x is equal to 1 by sin x. Okay. Now I am writing, I am putting comma, I am writing cosecant x function is defined for all values except sin x is not equal to 0. Or else you can write to define, or else we will write I am changing, you see. To define cosecant x function, sin x should not become 0. Is it correct? First you see. Why? Because sin x, if it becomes 0, it is going to become undefined. To define cosecant x function, sin x should not become 0. Okay. Now you write. What you are going to write? Now sin x is where 0. Sin x should not become means sin x function is 0 at n pi. Okay. You see one diagram also I am writing. All silver tea cups. Okay. This is 0 degree. This is pi degree. Okay. But values, how you are going to write? Value here also 0, here also 0, here 1, here minus 1. Okay. This 0 pi, again I am writing like this, you see. 2n pi, 2n plus 1 pi. I am writing this as sin x. Okay. 2n pi, 2n plus 1 pi. Okay. If you give any integer, minus 1, plus 1, 0, these two values are going to come. Okay. Together, 2n plus 1 pi, 2n pi will give 2n plus 1 n pi, sorry, n pi. 2n plus 1 pi, 2n pi. It will give n pi. Why? Because see, n is 0 means 0 here. N is 1 means 1 pi here. N is 2 means 2 pi here. Okay. N is minus 1. Minus 1 means here in this direction. Minus 2 pi here. Like this. Anything you can give n pi. Both will come n pi only. That means sin x function is 0 at n pi. Why? Because in these two areas it is 0. Here it is 1. Here it is minus 1. Okay. Sin x. Okay. Now finally you write. Finally what you are going to write? Sine cosecant function is continuous. Why? Because continuity is asking, na? Cosecant function is, why? Because see, x value should not become, see, domain of sin x, you write down. Domain of cosecant x is equal to r minus n pi. Any number you can give, but n pi you should not give. N pi if you give, what will happen? It is going to give 0. Function is going to become undefined. Okay. Now you tell me how you are going to write continuity finally. You write like this. Cosecant x function is continuous for all domain except n pi. Cosecant function is continuous for all domain except n pi. For all values of domain you write. For all values of domain. For all values of domain except n pi. Except n pi means you have to minus n pi. R minus n pi. Okay. This is case for cosecant. Like this again we are going to see secant x and cortex. Okay. First you note down this. We will go back to secant x. Okay. See, precondition is sin x and cos x we have proved at x is equal to c. Okay. At x is equal to c. Okay. Now you write this. We will go for secant x also. Okay. Let us go secant x. Okay, write down. Cosecant we have done. Secant x. Continuity of secant x. That is f of x is equal to secant x, that is equal to 1 by cos x. Is it okay? No, I am taking hx. Okay? hx. Why? Because f of x, g of x are already taken. H of x, continuity of secant x, comma, that is you have written. Okay. H of x is equal to secant x. Okay. That is equal to 1 by cos x. Secant x is 1 by cos x. Okay. See, secant x will be defined. Write down. To define secant x. To define secant x, comma, cos x should not be equal to 0. Comma you keep. To define secant x, cos x should not be 0. Why? Because cos x is 0 means it will go to become undefined. Okay. Now again you go and draw the circle diagram for cos x. You see here cos x circle diagram. All silver tea cups. Okay. Here 1, here minus 1, here 0 will come. Okay. Okay. These are values. But I am writing now angles. Angles means see, in these two areas we should not give 0. Cos x should not be 0 means 0 area. 0 area means see 4n plus 1 pi by 2, 4n plus 3 pi by 2. This is 4n plus 1 pi by 2, this is 4n plus 3 pi by 2. These two angles. Okay, these angles we don't bother. Why? Because cos x we are studying. Right? Cos x. Okay. Cos x we are studying. For cos x, these two angles we should not give. to not become 0. Okay. Now what are these combined angle? Combined angle is 2n plus 1 pi by 2. Okay. Now goes on, we will see. If you n is 0, any integer, n is 0 means 1 pi by 2, 1 pi by 2. N is 1, 2 plus 1, 3, 3 pi by 2. 1, 2, 3, 3 pi by 2. Again here. Okay. Either here or here. Okay. 2 means 2 into 2, 4 plus 1, 5 pi by 2. See, 4 pi by 2, 5 pi by 2, 5 pi by 2 here. Again 7 pi by 2. 3 means 6 plus 1, 7 pi by 2. Okay, this is in plus case. Minus case. Minus 1. Minus 1 means what will happen? Minus 2 plus 1. Minus 1 pi by 2. Minus pi by 2. Minus pi by 2 means here. Okay. Minus 2 if you give minus 4 plus 1. Minus 3 pi by 2. Minus 1, minus 2, minus 3 pi by 2. Like this, any side you can give. N is an integer. Okay. 2n plus 1 pi by 2 is a combined angle for this. Okay. Now you tell me, write down cos x is 0. Write down. Write like this, you see. Cos x function is 0 at 2n plus 1 pi by 2. Okay. 2n plus 1 pi by 2. Okay. Now you tell me continuity of secant x we can write. Okay. Domain for secant x implies x is equal to r minus 2n plus 1 pi by 2. Okay. The secant x means x domain what you are giving r minus 2n plus 1 by 2. 2n plus 1 pi by 2 you have to avoid. You have to avoid 2n plus 1 pi by 2. Anything you can give. Okay. This is the domain. Okay. Now you write continuity. The secant x is continuous. Secant x function is continuous at all values except 2n plus 1 pi by 2. Okay. Secant x function is continuous at all values except 2n plus 1 pi by 2. That means, see, 2n plus 1 pi by 2 or 2n plus 1 pi by 2 function is not defined. That is why secant x is continuous. Okay. Okay. Like this you write and close this secant x over. Again we go back to cortex. Cotangent means cot. Okay. Write down this. Okay. See, this circle diagrams you have to study very well. See, I don't know whether you have watched my trigonometry videos or not. Trigonometry, inverse trigonometry, all have explained these circle diagrams very clearly. You have to go back and study those. Let us go to cotangent or cortex. What we are writing? We are writing continuity of cortex. Comma h of x is equal to cot x, that is equal to cos x by sin x. Okay. Now again we write to define cot x, sin x should not become 0 like. Okay, write down. To define cot x function, comma, sin x should not become 0. If sin x becomes 0, automatically cos x by 0, cot x is going to become undefined. Okay. Okay. Now you tell me where sin x is 0. Okay, you go back. That circle diagram again, sin x. Sin x. Okay. In these two areas, these are going to become 0. Okay. Okay. What are these? Okay, what are these? This is 2n pi. This is 2n plus 1 pi. Together is going to give them n pi. Okay. Sin x is 0 to n pi. N is an integer. 0, 0, 1, 1 pi, 2, 2 pi, minus 1, minus 1 pi, minus 2, minus 2 pi. Okay. Like this. That means you write down. Sin x function is 0 at n pi. Okay. Now you write down. Cortex. Cortex function domain is equal to x is equal to, you see, anything you can give, but n pi you should not give. R minus n pi. R minus n pi. Okay, cortex you are giving r minus n pi. That means you write down finally. Cortex function is continuous. Cortex function is continuous at all values except n pi. Okay. At n pi, it is not continuous. See, cortex is continuous function. We are not giving that domain. Domain you are not giving means cortex is continuous only. Why? Because at n pi we are not giving the domain. Domain you are writing that domain r minus n pi. That means finally cortex is continuous. Okay. Write this. We will go for 23rd question. That will be last question for this class. Okay. Let us go. Okay. See the 23rd question. What they have written. Find all points of discontinuity of f where f of x is equal to sin x by x if x is less than 0, x plus 1 if x is greater than or equal to 0. Okay. Now you tell me, he himself mentioned in discontinuity and asking us to find continuity, so discontinuous points. Okay. For the sake, let us confirm or let us take that this is a discontinuous function. If it is a discontinuous function, where it will be discontinuous, you tell me? Why? Because minus infinity to up to 0, not equal to 0, up to 0, sin x by x is continuous. Why? Because any value if we give, sin x will give some value, x also will give some value until it is 0. Okay. Why? Because the denominator should not become 0 like we know. But even then if equal to 0 is there, equal to 0, again they have given another function, you see, x plus 1. That means 0 plus 1. This is also continuous. At 0 it is continuous. After that 0 also this is continuous. Any value if you go automatically, that value plus 1 is going to come. That means this is a continuous function up to plus infinity. That means by seeing we can say that this is a continuous function. With our experience I am telling. Not with what we can say after doing. Without doing also we can say that this is a continuous function. But he is telling that this is discontinuous function. How it is going to become discontinuous? If at all any discontinuity is there, at 0 only it has to be discontinuous. Okay. Let us find continuity at x is equal to 0. Okay. Write down. Continuity at x is equal to 0. Okay. Write down. Continuity at x is equal to 0. Limit extends to 0. F of x is equal to, limit extends to 0. Equal to 0 means x plus 1 you have to take. X plus 1 that is equal to. Now you apply limit 0 plus 1 that is equal to 1. Okay. Now this is center limit, like not left hand right hand. Center limit has come 1. Okay. Now you tell me, is it required to take right hand limit? Why? Because greater than 0. You see, greater than 0 also same thing is going to happen. Not required. We can say this is right hand limit. Why? Because see, right hand limit also greater than 0, x plus 1 only. Okay. Write down. right hand limit comma limit extends to 0 plus f of x is equal to 1. I have not done again. Why? Because same thing is there. That is why I have written like this. Or else you avoid this f of x, so directly you write 0 plus x plus 1. Okay. 0 plus also you are going to do 0 only. See, normal cases I am talking about. In normal cases, 0 plus or 0 minus. Rather 0, we will first take C or K. C, one limit you have seen. C plus C minus also, if you want to see, C plus or C minus are slightly less than or greater than C. That is why you can take C only. Okay, while applying limit. But function, you see, C plus C minus function is changing with that function you have to take, but you have to apply C value only in normal cases. But this is not applicable when division is there like that. In special cases, you have to avoid this. If 0 by 0 comes means, 0 by 0 comes means any derived standard is there. Here 0 by 0, limit extends to 0, sin x by x is as per sandwich theorem 1 is there. There you can apply directly 0. Okay, now we are applying. Okay, write down left hand limit. Write down left hand limit. This is right hand limit. Left hand limit. Comma limit extends to 0 minus f of x is equal to, see, 0 minus means you have to take this function. Limit extends to 0 minus sin x by x. Now what I am writing, you observe carefully. I am writing limit extends to 0 sin x by x. Is it correct? 100% correct. Why not correct? Why? Because see, if at all 0 minus creates any problem in division or something area, then you are not going to write 0 minus. But here it is not going to create any problem. Even if you apply like 0 also, limit extends to 0, sin x by x value we know. As per sandwich theorem, it is 1. Okay, write down. Okay. As per sandwich theorem, limit extends to 0, sin x by x is equal to 1. Therefore, left hand limit is equal to 1. Okay. Now you tell me right hand limit is 1, left hand limit is 1. If both are 1, then you see main limit also 1. Now you tell me, is this function continuous or discontinuous? Continuous. But he is asked us to write discontinuity points. That means what you have to write? There is no point of discontinuity. This is a continuous function. Okay. Before that you write like this. You see what I am writing. Limit extends to 0 minus f of x is equal to limit extends to 0 plus f of x, that is equal to limit extends to 0 f of x. Limit extends to 0 f of x also 1. Limit extends to 0 minus f of x also 1. Limit extends to 0 plus f of x also 1. All are 1. That is why equal to I have written. Okay. This is a continuous function. Write down. This is a continuous function. There is no point of discontinuity. You understand now? This is a continuous function. There is no point of discontinuity. Point of discontinuity asking. There is no point of discontinuity. Why? Because this is a continuous function. That's all. Okay. Let us close this class. Still several questions are there. We will do. Next class we will try to do as many as problems. Okay. Thank you very much.